Now, this is the second part of our topic under wave, and it will be based on light energy. And don't forget, if you have not watched video under the first part, please go and do so for you to understand this one very well. Now, previously you must have learned about energy, and when you are mentioning forms of energy, one of it is what? Light energy. Therefore, if you are asked to define light, you can say light is one of the forms of energy called luminous energy, because it causes sensation of what? Fission. Now, after definition of light energy, what are the things again that you need to know about this topic? You must know sources of light. Now, if I asked you what are the sources of light, I know you will mention many things. We have our bulb, we have our electric lamp, we have our torch, and so on and so forth. But do you know, you need to know how to classify them. So to classify the source of light, so we have two categories. So in that case, the first category is whether that particular source of light is a natural one or artificial. So when we are talking about natural source of light, we have sun that all of us know is natural. It produces what? Light for us every day. Then another one is star. Star is also what? Source of light, and it produces light. And then another one which is natural is that of what? Fireflies. There's one insect that produces what? Light by itself. When it's also what? One of the natural source of light. When we have artificial, which is common, our electric bulb is artificial. Then our filament lamp is artificial. Fluorescent is artificial. What of end lamp of a car is also artificial. Our torch is also artificial source of light. Then another way of classifying the source of light is to say whether the body is what? Luminous one or non-luminous one. When we say luminous, they are the body that can produce light by themselves. They do not depend on another body. And most of natural source of light, they are what? Luminous. Especially sun is luminous body. It produces light by itself. It does not depend on any other body. Yeah. Then another one is star also. Star is also what? Luminous body. Firefly is luminous body. All of them, they can produce light by themselves without depending on any other source. Now, what of electric bulb? Electric bulb too can produce light by itself. Then what of fluorescent light? It can produce light by itself, though they are what? Artificial, but they can produce light by themselves. Then what of end lamp of a car? Our torch. So they are what? Artificial, and they are still what? Luminous body. Luminous body are those ones that can produce light by themselves. But do you know that we still have another body called non-luminous? Non-luminous in the sense that they can produce light, but that light, they depend on another source of light. If there's no light from another source, they cannot generate light by themselves. Do you know that the moon that produces light for us, it depends on something. The moon depends on light from the sun. So which means moon cannot produce light by itself. Another one is what? Shiny surface like glass. When you on light on the glass, you see the reflection. So which means the light that we always see from the moon is as a result of reflection of light from the sun. The same thing applicable to what? Shiny surface like paper. Paper also, when on light on it, it will reflect it. It not look as if it is the one that produced that particular light, but it reflects from one source. So all those material that depends on another body, we call them non-luminous body. Don't forget, moon is non-luminous body. Shiny surface too is non-luminous body. Glass is non-luminous body. Those are the four ways of classifying the sources of light. I said artificial, then we have natural, then we have luminous, then we have non-luminous. Now, after that, let's go to how light. Don't forget, light is one of the electromagnetic waves that require no medium. but it moves from one point to another. Then how does light passes through material? So that's some material that will allow light to pass 100%. That is, when 100% ray of light get to them, they will allow the whole 100% of ray of light to pass through them. When we have some, we stop part of it, they will allow less than even half of it to pass through them. While some will not even allow any part of the ray of light that fall on them to pass. Therefore, we classify material into three. The first one is transparent material. Transparent material will allow the whole light that falls on them to pass. For instance, if you have a transparent material like glass, like this, and the ray of light is coming like this, so you can see that we have four. The all four rays will get out through them. So this type of material, we call them transparent material. Example of that is what? Glass. It's like plain glass will allow the ray of light to pass 100%. Then we still have another material called translucent material. A translucent material will allow even less than half, less than 50% of the rays of light that fall on them to pass. So in that case, if you have them like this, you have translucent material like this, then the ray of light from outside is coming like this. Out of these five, maybe only two that will get out of the translucent material. Any material that will stop part of matter, that will not allow 100% of the ray that fall on them to pass through, we call them translucent material. So example of translucent material is frosted glass. Then we have our tissue paper, it's also translucent material. But what of the third one? I said we have three. We classify material into three. The first one is transparent. The second one is translucent. While the third one is opaque material. Opaque material will not even allow any ray of light that fall on them to pass through, no matter how plenty or more they are. Like this one, what you just see at the back of the opaque material is what? Darkness. You just see darkness. No ray of light will pass through them. Example of that is wood. We have blood. What? So those material, they will not even allow ray of light to pass through them. Then we are talking about ray. What is the meaning of ray? What is that first question that I'm supposed to ask? What is the meaning of ray? Ray, a ray is a path or direction through which light energy flows. A ray is a path or direction through which light energy passes or flows. Like we indicate ray with a line, a straight line, and an arrow. Like this is a ray. So when we now combine rays together, we have beam. That is combination of two or more rays form beam. Like this is a ray, but when you have this 1, 2, 3, 4, or more than this, or once it's more than one, we call it what? Beam. We now have three types of beam of light. We have three types of beams of light. So when rays from different ways come together to a point, we call it what? Convergent beam. Convergent beam. That is when, just like when you are coming to school in the morning, students will come from different areas, but all of them, they will converge at a point in the school or on assembly. So we call it, when you have rays from different directions and they all meet at a point, we call it what? Convergent beam. But when you have rays of light from a source and they went to different directions, so we call it what? Diverge. That is when you close in the afternoon, you are going. So then we leave a compound, a school compound, all of them, then they will go to different directions. We call it what? Divergent beam. The third one is when we have ray of light that they are parallel to each other, combination of what? Rays, and they are parallel to each other. We call it what? Parallel beam. The first one we have this ray, this. So as it is like this, we cannot conclude whether it is what? A convergent beam or divergent beam. For instance, if I just put arrow like this, the arrow indicates that they are coming from this side, and all of them they meet at a point. So in that case, they converge. We call it convergent beam. But if arrow is pointing outwards, like this, so this shows that the ray of light from this source and each went to different direction. In that case, we call it what? Divergent beam. So that is what the types of beam we have. We have convergent, we have divergent, and we have parallel beam. For parallel beam, just like we have parallel lines, the only difference that you must put arrow. Don't forget, we are talking about ray. There must be an arrow. If you draw a line without that arrow there, it's not a ray. We have this, so that what? The rays are parallel to each other. So that is, we call it what? Parallel beam of light. Now the next one is rectilinear propagations of light. And if you look at the word, if there's indication of line there, don't forget, when we are discussing about type of motion, we say movement of a body on a straight line is called what? Linear motion. Therefore, this one means rectilinear, that is the evidence so that light travel on the straight line. And don't forget, when we are talking about properties of wave, though we said wave can what? Can reflect, it can refract, but it can only reflect when the wave hits another shiny surface, and it will reflect also on a straight line. Light doesn't bend. You understand? It can only reflect or refract or diffract. So when you are talking about rectilinear propagations of light, it means evident to show how can you tell us that light travel on a straight line. We now have different ways by which we can show that light travel on a straight line. The first one is, I can easily even use myself. If I have thoughts in front of me, I have light like this. What do you think will happen at the back? So at my back, we are going to have shadow. That shadow indicates that at my back, light cannot curve like this to reach my back because it travels on a straight line. You have an object like this. So a ray of light is coming like this because that is, we are talking about opaque objects. We have an opaque object like this. So you see that this place, all this ray will be blocked by this. But because light travels on a straight line, all this place will be what? Will be in total darkness. And that total darkness is called umbra. So this ray, as many light can travel on a curve or bent road, so it's supposed to come like this, so that there will be no any darkness at the back of this opaque object. So one of the way of showing that light travel on a straight line is to place object in front of the light, and then you see the darkness at the back. That is the shadow image shows that light travel on a straight line. Not only that, we can still use what? Cardboard. Arrange a cardboard that contains holes. Let's say I have my cardboard like this. We have holes here. Then if I have another one here, so like this, and I have another one like this. So if I will just place my light here. So the light will pass through this space, but because this space, this hole and this, they are on a straight line. So the light will still appear around this place. But because this one and this hole and this hole, they are not on a straight line, what will now happen? When the light gets to this place, light cannot come to this place. So if you now place any other cardboard here, what you are going to see here is what? Darkness. You're going to see darkness. So that light cannot travel through what? Bent road, but it travels on a straight line. So another way of showing that is to use what? Pipe. We can also use pipe to show that ray of light or light wave travel on a straight line. Take a straight pipe like this, have this pipe, and put your light here. So at the end of the day, you see the light here. You see the rays of light at the other end of the pipe. But if you have a bent one, then put your ray of light here. What do you think will happen? The ray of light will just come here and it will stop here. This place will be in darkness, such that the ray of light cannot come. Therefore, this is another evidence to show that light travel on a straight line. And we can still use what? Eclipse. Eclipse. Eclipse means cannot see. That is, the ray of light cannot reach, or the darkness. So when the sun, the moon, and the earth, they are on a straight line. Do you understand? The sun, moon, and the earth, they are on a straight line. Don't forget, the moon and the earth, they are opaque objects that cannot allow ray of light to pass through. So in that case, the one that is at the back of other one, we experience darkness. Either total darkness or partial darkness. Now, for instance, when we have the sun, let's say we have the sun like this, and this is what? The source of light. Then you now have the earth here, and don't forget, the moon is a satellite to the earth. So the moon is here around this place, revolving around the world, the earth. So the ray of light from here just come like this. The ray of light from here also come like this. So what will now happen? The ray of light from here will be stopped here. So in that case, this moon will be in what? Total darkness. And in that case, we cannot see the moon. We cannot see the moon means eclipse of the moon. And that's what they call lunar. So we cannot see the moon. Lunar eclipse. Eclipse of the moon. Then, if we cannot, is it possible for us to say we cannot see the earth? We are already inside the earth. So in that case, the other way around, we're supposed to say we cannot see the earth. If the image of the moon casts shadow on the earth, we're supposed to we cannot see the earth. But because we are already in the earth, so we now say, okay, the moon blocks us, so we cannot see the sun. The sun, we now call it eclipse of the sun. That is solar eclipse. So in that case, to look like this, the sun is here producing the light. Then if you now have the moon here, then the earth here around this place. So if the ray of light is coming like this, so another ray of light, or let's say this place now, all this place, they are going to be in what? In darkness. Therefore, this part of the earth, we experience darkness. So the people here, they are born in darkness. we're supposed to say the eclipse of the earth. But because we are already inside the earth, we cannot see the earth. We now change it, okay, we are in darkness, we cannot see the sun. So we now call it what? Eclipse of the sun. We have eclipse of the moon, we cannot see the moon. How I said eclipse means what? We cannot see the darkness. But the other way around, this eclipse of the sun, it means the sun is in darkness. Sun can never be in darkness. It's the source of the light. It's the earth that is in darkness. But because the people are at that particular point, they are in darkness, they are blocked by the shadow of the moon. So they cannot see the sun. They now say eclipse of the sun. So in that case, that one is even telling us that let's travel on a straight line. Otherwise, this one, the ray of light that's coming like, it's supposed to come like this, so that this moon will not experience darkness. So the same thing will have happened here if ray of light do not travel on a straight line, but rays of light travel on a straight line. Otherwise, we wouldn't have experienced any darkness here. So those are the evidence to show that light travel on a straight line, which is called rectilinear propagations of light. So the next one is pinhole camera. We can use that one too to show that ray of light travel on a straight line. It looks like this, just like bulbs, like this. So if you have an object here, and we have this as a luminous object here that will produce what? Light. So the ray of light will move from the top like this to this place. So in that case, this one will come and form the top, the edge, this one here. I'm going to have it here. Then another ray of light from here will move like this. So that one too will go and form the bottom or the base. So in that case, we are going to have the image like this. So if you now look at the image, what can you now say? So it means the image turned upside down. It's called inverted. The image is what? Inverted. Then, as you can see, it's even bigger than the what? Object. It's what? Magnified. Bigger than object. That will now lead us to what? To formula for finding magnification. What is magnification? How big, how multiple the image is to that of object means the ratio of image size to that of object size. It can be the ratio of image distance to that of what? Object distance. Therefore, magnification is equal to, like this one. This is our image. So let's say this one is OM, then XY. So the magnification of this object will be OM over XY. And what do you think will be the unit? So since this one is distance and this one is also distance, so if it will be in meter, this one will be meter, this one will be meter. So the meter will cancel meter. So that means magnification has no unit. You can still use image distance over object distance. What will be the image distance? Image distance is from this place to this place, because this is what the hole is. We call it pinhole camera. Pinhole camera. So we can still have a magnification is equal to image distance. If this one is nm, so and from here to here is r, so it will now be ml over lr. So at the end of the day, we discover that this one to the unit will cancel each other, so it will leave no unit. So that will be the end of the end of part 2A of this. The next one will be reflection of light wave on a plane surface and curved surface.